Hello everyone, in this video we are going to see about the arithmetic expression and how it is evaluated using the stack. We know that stack is the data structure, linear data structure which has the last in first out order of operation. The nature of this last in first out operation helps in evaluating the arithmetic expression easily. So normally when you write the expressions, so before that, what is an expression? Expression is the combination of operand and operators. In mathematics we say C is equal to A plus B or A plus B is equal to 5. So the combination of operands and operators is called as an expression. Normally the way we write in our day-to-day life, that is the way in we write the equation is the infix notation. As the name implies, the operator is fixed in between the operand, so it is called as an infix operation, in which each operator is written between the two operands, that is A plus B. Here we can see this plus is in between A and B, so this type of notation is called as an infix notation. With this notation, we must distinguish between the two different equations. So how to differentiate? We have to use the parenthesis as well as the precedence of rule, that is the operator precedence rule. So by using this parenthesizing and also how to use the operator precedence method, we can distinguish the equations on how the equations must be calculated correctly. Now let us see the infix notation. Here we can see this is the normal type of notation we use in our mathematics, where all the operators lies between the operands. Here A, B, C, D, E, F are the operands and the minus, star, slash, plus are the operators. So this is the normal way we write any expression or formula. Now in the postfix notation we can see here AB minus CDE plus slash F plus star. This is the way how the postfix notation is done in the using the stack. Let us see in the next video how to convert the infix notation into postfix notation. So for now you just listen how the expression are written by fixing the operator at the back of the operand. So this way of representation of expression or a formula is called as postfix notation, because as the name implies, postfix means the operator is fixed post, that means after the operand. Let us see Polish notation. What is the Polish notation is? This notation is named after the person Polish, where the notation is also called as a prefix notation. Actually, what is prefix notation? As the name implies, the operator is put in front of the operand. Now A is the operand and plus is the operator. Now writing is an infix as A plus B. Here the Polish notation uses the operator in the front of the operand. So this is the prefix notation of writing the equation. This is named after the person Polish. And we have another notation called reverse Polish notation, that is the postfix notation. In last slide we have seen the postfix notation. The postfix notation is also called as reverse Polish notation. So Polish notation uses the prefix representation, whereas the reverse Polish notation is called as the postfix notation. So now it refers to the analogous notation in which the operator is placed after its two operands. No parenthesis is required in reverse Polish notation also. That means here when you say plus AB, there is no brackets. Same way when you write A plus B, there is no brackets. So these Polish notations eliminates the use of the brackets, and the order in which the operands and operators are placed helps to evaluate the expression. Stack organized computers are better suited for postfix notation than the traditional infix notation. Because why? Because the stack always has the property of last in first out. So this postfix notation fixes the operator at the back. That means the operator will be put on the top of the stack. When any expression is passed inside and put inside the stack, the operands are first put and then the operators. So when an operator is reached, the two next operands are evaluated. That is called as the similarity by which the stack operates, and as well as the notation is, or the equation is evaluated. So it is better because as the nature of the stack and the postfix notation resembles the same, the operation is also very successful and easier. Thus, the infix notation must be converted to the postfix notation. Normally, when the system solves any equation given by the input by the user, it first of all converts the infix notation to the postfix notation. Now let us see how the conversion of infix notation to postfix notation takes place. So how to convert? First, the conversion from infix notation to postfix notation must take in the consideration of the operation hierarchy. We know that what is a hierarchy? Hierarchy is the order in which the operation is performed. Normally, when you see an equation, we start evaluating from the left to right or by the brackets how it is placed. But in the system, the computer converts the infix notation into postfix notation based upon three levels of precedence. That is the hierarchy of the operators. So in the any expression given, if the exponent operator comes, this is the exponential operator, this is given the highest priority. And next is the multiplication and division from the left to right. As the equation is scanned from left to right, multiplication and division are given the same level of precedence. Whichever comes first will be evaluated first. And next is the addition and subtraction, which has the lowest hierarchy. So when in the same equation addition and subtraction comes in any order, the order will not be changed. The addition will be whichever operator either plus or minus come, it will be evaluated first in the order from left to right. So now let us see how to evaluate the arithmetic expression. So in order to evaluate the arithmetic expression, first we have to convert the expression into postfix notation and then push the operands into the stack in the order they appear. As we see in the previous slide, stack nature resembles the reverse Polish notation. So the operations are performed effectively using the stack method, using the stack storage. When any operator encounters, then pop two topmost operands for executing the operation. So in the stack, the system keeps on pushing the expression by the operands and then the operators. When two topmost operators are there and when an operator is reached, the system does the operation between the two operands. Let us use the example to understand the concept easily. After executing, push the result obtained into the stack. So normally the result will be pushed back to the top of the stack. After the completion execution of the expression, the final result will be pushed into the top of the stack. So top of the stack always contains the recent element which is in the stack. Now let us see with the example how this infix notation 2 plus 4 into 4 plus 6 is converted into postfix notation like this, and then how the result is evaluated. So you can see here, first these brackets are considered 2 and 4, the operator is plus, so 2 4 plus, and then next bracket is considered 4 and 6, so 4 6, the operator is plus, it is put. Now after that, this is one, like consider this as one variable and this is another variable, so this is one operator. So this is first put, already we have put here, this is put second we have put here. Now the operator remaining is the multiplication operator, so it is put in the last position. Now we can see all the operators are placed after the operands, which is the postfix notation. Now by evaluating 2 plus 4 is 6 and then 6 plus 4 is 10, then the multiplication is done between 6 and 10. The answer given is result is 60. Let us see how the stack is involved in calculating this expression. So first 2 is pushed into the stack, and then 4 is pushed into the stack, and then the Polish notation, the reverse Polish notation contain the plus operator. So when any operator is reached, the top two operands are performed and it is pushed into the stack. Same way, the top two operands are 4 and 2. So 4 plus 2 is 6. The operator is 6. So this 4 plus 2 is taken and this operation is done and the answer is 6. That is pushed back to the stack. Now the stack has only one operand. Now the equation is scanned next. Now the next operand is 4. Now 4 is pushed into the stack, but when this 4 is pushed, there is no operator. Only when the operator is reached, the operation is performed. So previous answer 6 is here, and now 4 is pushed now, and now the system scans the next element, which will scan the value 6. It is pushed into the stack. So this is the new values 4 and 6 from the next part of the equation, and then afterwards it encounters the value plus. So when the plus is reached, these top two elements 6 and 4 are added and the answer is pushed back to the stack. So now this stack pointer contains the answer of the two elements 6 and 4. Now you can see here there are two operands 10 and 6, and then what is the operator, which is the star is the operator, and the operation is done between the operands 10 and 6. The operation is multiplication. So 10 6 are 60. The expression is evaluated. So initially to convert this to evaluate this expression, first of all the system has to convert the expression infix into postfix. So by seeing this postfix, 2 is pushed, 4 is pushed, and when it see the operator, these two values are operated. So 2 plus 4 is 6. The answer is pushed back to the stack. Likewise, it see the value 4, there is no operator, it goes next, see the next value 6, so it sees the next operator plus. So these 4 and 6 are operated by this operator, and then answer 10 is reached. Now here 2 plus 4 is 6, and then 4 plus 6 10, and it reaches the next operator multiplication. So 6 tens are 60. The answer is given as 60. The same is done using the stack over here. So this is the simple way how the stack uses the LIFO property to evaluate the expression. So whatever the lengthy expression is given to the system will first convert all the infix into the postfix notation, and then it is pushed into the stack and the operation is performed. Let us see in the next video the algorithms on how to convert the infix into postfix and also how to evaluate the postfix expression. Hope this concept of using the stack in evaluating the arithmetic expression is easy to follow, and thanks for watching.